Hello, this is question 15 on your AQA paper 1, November 2020. So you have a region enclosed between the curves e equals e to the power of x, which is this one, and y equals 6 minus e to the power of x halves, which is this one. And the line x equals 0 is here, yeah? So it's this area. So that the exact area of the shaded region is this value here. So if we want to find the area, what we are going to do is to integrate between this x equals 0 and this value of x. Yeah, and we are going to integrate the difference between the top line, which is this function, and the bottom line. So if we have that this is y1 and this is y2, we are going to integrate, and this is, let's say, x1 between 0 and x1, y1, which is the top one, minus y dx. Yeah, that's what we are going to try to find. So the first thing we are going to do, I would say, is to find this point. It's the point of intersection between this line and this line. So we are going to solve simultaneous equations. One is y e to the power of x, the other one is 6 minus e to the power of x halves. So we can make the y equal, and we have e to the power of x is 6 minus e to the power of x half. If you notice, this is some function, and this is the same function squared. Yeah, so e to the power of x is e to the power of x halves squared. So we can work with it as a quadratic. We have e to the power of x plus e to the power of x halves minus 6 equals 0, which is the same that having, for example, y squared plus y minus 6, yeah, equals 0. So it's a quadratic. If we factorize that quadratic, we have 3 minus 2, right? So we are going to have e to the power of x halves plus 3 and e to the power of x halves minus 2 equals 0. So my two solutions are going to be e to the power of x halves equals minus 3. That cannot be, so e to the power of something cannot be negative, so this is not giving me solutions. And the other one is e to the power of x halves equals 2, which means x halves is going to be ln 2, which means x is 2 ln 2. Or if you want to, these two can go squaring the 2, so it could be the same that ln 4. Yeah, either way. So this is this x1 that we wrote here. So this is ln 4. And now what we are going to do is to integrate between 0 and ln 4 the difference between the two graphs. So the top one minus the bottom one. The top one is this one. So I'm going to integrate. The area is going to be the integral between 0 and ln 4. Top one we say is e to the power, no, it's the 6 one. So it's this one, 6 minus x, no, 6 minus e to the power of x half minus the top one, which was this one, dx. We are going to separate, or we can integrate each of them, and the integral is quite simple. So I'm going to write, if I integrate 6, it's going to be 6x. If I integrate e to the power of x half, it's going to be e to the power of x half, but I'm missing a half, so I'm going to multiply by 2. So minus 2 e to the power of x halves. Because when I derivate this function, I have the same function and then multiply by a half. That with these two are cancelled, yeah? And the last one is going to be minus e to the power of x. And this is going to be between 0 and ln 4. If I substitute ln 4 here, I have 6 ln 4, 6 ln 4, then e to the power of ln 4 divided by 2 is 2. You can do with a calculator, or you can think that, so briefly, is e to the power of ln 4 divided by 2. And we know ln 4 was 2 ln 2 divided by 2. We can cancel this, and we have e ln 2, which is 2. Yeah? So this bit is 2 altogether. multiply by 2, these two at the front, so I have minus 4. And then e to the power of ln 4 is 4, so minus 4. And then minus, I substitute the 0. So this bit is 0, but then I have e to the power of 0 is 1 times minus 2. So I have minus, this is all when I substitute by ln4, or f of ln4, minus, I substitute the 0, yeah? So when I substitute the 0, I have minus 2 times 1 minus 2, and minus 2, minus times 1 is minus 1, yeah? So I have 6 ln4 minus 4 plus 2 plus 1, yeah? That makes sense, which is plus 3, no, minus 3 plus 3 minus 5, yeah, which is, I think, what we had to find, yeah, is this one, is this value here, yeah. And that's all with this question. So we have to find the point of intersection to see the limits of integration, and then we are going to integrate the difference between the top one and the bottom one, yeah, and that's all.